Today we are solving the problem of instantaneous center method of slider and crank mechanism. The problem is a slider crank mechanism is as shown in the figure. The crank of length 6 cm. This is the 6 cm crank length is given. Rotated at uniform speed of 300 rpm. 300 rpm it is rotating. The length of connecting rod is 25 cm. This is the connecting rod 25 cm. When the crank has turned by 30 degree from the inner dead center, this is turned 30 degree towards the inner dead center. It is the inner dead center, this is the outer dead center. Locate all the instantaneous center of the mechanism. We have to locate all ICRs and find the angular velocity that is of connecting rod, that we have to find out the omega 3, and also the velocity of the piston we have to find out. Now we are solving this problem now. I will consider the scale here. Scale 1 centimeter is equal to 2 centimeter I will consider here. I'll draw one horizontal line at this point. This is a fixed end. Degree towards the inner dead center. This is 6 centimeter. Therefore, I have to consider the half, that is 3 centimeter. Got an arc here. That is 3 centimeter here. Next connecting rod is 25 centimeter. Half is nothing but 12.5 centimeter. .5 centimeter. Draw a piston here or a slider. And connect this connecting rod here from this point to this point. Go for the naming the link. The fixed link I will consider as a 1 link 1, 1, 1, and this link as a 2, and connecting as a 3, and piston or a slider as a 4. Now I will go for locating the permanent and fixed ICRs. This is the fixed ICR I12. This one will be permanent ICR I23. And this is the slider with respect to connecting rod. It becomes I34, and with respect to one fixed end it becomes what? I14. If it is in the case of a slider 14 always moves parallel to this line, and in this way. I have to draw a line exactly perpendicular to this one and parallel to this portion, and this line can be transferred for this point or this point depending upon the condition, and this line will be infinite. Okay, next we are going for instantaneous center. That is n is equal to n minus 1 divided by 2. There are 4 links, 1, 2, 3, 4 link, 4 into 4 minus 1 divided by 2, it becomes 6. Next we are going for instantaneous center in mechanism. link. There is a table 1, 2, 3 and 4. ICRs 1, 2, 1, 3 and 1, 4 dash. Next 2, 3, 2, 4. Next is about 3, 4. From the figure, go for rotation of the permanent and fixed ICR. This one is fixed, therefore go for rounding of this one. 2, 3, rounding of this one. 3, 4, rounding of this one, and 1, 4. This is obtained from the figure. Unknown is 1, 3 and 2, 4. This is neither fixed or neither permanent ICRs. Now we have to find out this one. I13. Before this one, we have to draw one circle here. Circle we have to draw it of unknown radius. Take up any radius, draw a circle and divide into 4 parts because it is a 4 link. If it is a 6, you have to go for hexagon. Divide into 4 parts. One, 2, 3 and 4. Based on circle, we have to write this one. Unknown is 1, 3. Draw a dotted line. 1, 3. The two triangles will be obtained, one this side and one more this side. First triangle is I12, I23, and second is I14, I34. In this way, we are obtaining the neither fixed and neither permanent ICRs. First one is completed. Next 2, 4. Draw a dotted line from 2, 4. The two triangles will be obtained here. I24. First one I23, I34, and second is I12, I12, I14. Both are completed. Now based on this one, we have to draw the lines here. Now first one is 1, 3, 1, 2, 2, 3. Next is 1, 4 and 3, 4. This is the combination. Therefore extend this line till it reaches to that line. Where it meet or intersect, that intersection point becomes, this point becomes I13. I13. And next point is about 2, 3, 2, 3 and 3, 4. This is the 2, 3 and 3, 4. Next is about 1, 2 and 1, 4. This is the 1, 2 is there. This is the 1, 4. And therefore 1, 4 can be moved from this point to this point here. That's the speciality of the slider here. You can move this line here. And extend this 2, 3 and 3, 4 here. This point becomes your I24. These are neither fixed neither permanent ICRs. Now, as per the question, we have to find out the angular velocity of a connecting rod. That is omega 3 we have to find out. This is omega 3. Because omega 2 is given, omega 2, 2 pi n divided by 60, that is 2 into pi into 300 divided by 60, the value will be around 31.416 radian per second. And next we have to find out omega 3. How to find out omega 3? By using this equation. V is equal to I23. First we have to write omega 2 into I. Every time you have to write 1 and the 2 here, comma, and same I23. One more combination of this one is VI23. Now we have go for the 3 here, omega 3 into I13 and I23. There are two expressions. First expression I will take it as I123 is equal to omega 2 already is given 31.416 into I12, and this is nothing but the actual distance is 6 centimeter. I will take directly 6. The value will be 188.496 centimeter per second. I will substitute here in this formula. It becomes 8.8496 omega 3 into 13 and 23. We have to take this distance, and this distance is around 14.3 into 2. There is scale you have to consider into 2 here. In here I have taken directly, but here it is 14.2 because it is a scale 2, therefore we have to multiply into 2. The answer will be around 6.5907 radian per second. This is the angular velocity of a connecting rod. We have to find out the velocity of the piston. The velocity of the piston, it is written as VI34. And the formula will be first omega 3 into I13 comma I34. Omega 3 is already known here, 6.5907 into I13 and 34. I13 and 34 will be 8.6 into scale. The answer will be 113.36 centimeter per second. That's the answer for velocity of the piston. Thank you for viewing.